Hello everyone, I'm Chol, Linux cluster on CentOS 6 and 7, Chapter 10, Cluster Logical Volume Management, normally we say the CLVM. Main topics, this chapter will cover this kind of topics, LVM introduction, and the LVM the architecture, and the CLVM overview, and LVM components. And the number 5, PV, the physical volume, VG, the volume group, and LV in the logical volume group administration. Logical volume management normally say the LVM. So LVM means LVM normally make a layer of the abstraction of a physical storage to create logical storage volumes. So normally LVM mean the logical. So using or over the physical storage, we can create this kind of logical storage volumes using LVM. And the LVM also provides the much the greater flexibility than using physical storage directly in many ways. Even if we don't use LVM, we can use the physical storage for the clusters. But normally the LVM the supply greater the flexibility compared to physical storage management. And the logical volume management is not restricted to physical disk size by logical volume. So normally the physical disk size normally is restricted to use, but using this kind of physical disk, anytime we can control the size of logical volumes. And the hardware storage configuration hidden from the software. So even if the software doesn't know our hardware storage configuration, no problem to supply this kind of the disk to the clustering system. So possible to be resized and moved without stopping applications or unmounting the file system. Even if we don't stop the application, or even if we unmount the file system online, no problem to resizing and moving this kind of the disk using LVM. If we use the logical volume, we have this kind of advantages. First one, the resize the storage pools. So I already told you, extend the logical volume or reduce logical volume inside. Anytime we can control this kind of logical volume size. Flexible capacity. So extend the file system across multiple disks and aggregate disk and partitions into single logical volumes. So even if we have the many kinds of the multiple disks and the partitions, no problem to create this kind of logical volume. Convenient device naming. So also after we create this kind of the logical volume, anytime we can change or create the device naming. And the online data the relocations. So it means move data while your system is active. So even if your system supply this kind of online data, but no problem to move this kind of data. Normally, we say this one, online data, the locations. Disk striping, so next page I will explain this one. Create logical volume to stripe data across two or more disks to increase the throughput. So for the better throughput, normally we can use the striping with over two or more disks. And the mirroring volumes, also this one is similar to the backup, so provide the convenient way to configure mirror for your data. So if you save your data to the disk, then we can copy all this data to another disk. We normally say this one mirroring. Volume snapshots means take the device snapshots for consistent backup or to test the effect of the changes without affecting the real data. So if we use the snapshots, maybe we can copy the real-time the data with a kind of consistent backup. Next page, I will explain this one. Okay, data striping and the mirroring. Normally we say data striping is a RAID 0, data mirroring is a RAID 1. So in case of striping, here there are two disks, disk 1 and disk 2. So per each, the disk can save the data, but the data block is different. Here, block 1, block 3, and block 5, and block 7. Here, block 2, block 4, block 6, and block 8. So in this case, we can use two disks at the same time to save our data. So maybe the speeding of the data storage, the saving is very fast compared to the other method. But the problem is that if we the disk 2 is so corrupted by some reason, then we cannot recover this data. And the mirroring, here also disk 1 and the disk 2. And the disk 1 save the this kind of data, block 1, block 2, block 3, block 4. Also, disk 2 also saving block 1 and block 2, block 3, and block 4. So, disk 1 and disk 2 is the same. So, we can say this one, the perfect backup disk of disk 1. So, in this case, only, even if there are two disks, we can save only one disk. So the speed a bit late compared to the striping, but the stability compared to striping is better. Volume snapshots. So this is the data we want to save, and for this data we want to make a kind of the backup data. So in this case we can use the snapshot. So for example, AM11 we can thus backup this data and the name like this. And the 2 p.m. also we can the backup. And the 6 p.m. also we can backup. So according to the consistent backup, maybe the backup data will be the different according to the time frame. So 11 p.m. and the 2 p.m., 11 a.m. and the 2 p.m., the 6 p.m.'s data will be the different. So according to the process of the all data backup, then this kind of the snapshot also will have the different data like this. 1, 2, 3. So if we want to use this kind of snapshot, volume snapshot, we have our disk, the data we want to snapshot for this one. So this is a real data, and this is, you can say, a kind of virtual data. LVM architecture. So to understand LVM, we have to understand three kinds the topics. First one, physical volume. Second, volume group. Third, logical volume. So physical volume means normally coming from here, normally partitions, for example, DVSDD, SSDC, or SDB1 like this. So to create this kind of physical volume, normally we can use this kind of partitions. And the partitions can be the data, only the disk name, like this DVSDC, DVSDD, or DVSDB1. This is the name of the kind of the partition. So both can become the factor of the physical volume. So if we want physical volume, normally we can use this command pv create, and this kind of using this kind of physical volume, we can create the volume group using this command vg create. If we create this kind of volume group, normally this device will be saved here, dv/volume group 1 or 2 like this. Using this kind of volume group, we can create the logical volume like this. So this kind of logical volume, if we create the logical volume using this command lv create, then this data will be saved here, dv volume group name and logical volume group name. So LVM logical volume, the initialize the physical device first, like a partition or whole disk. Normally we say this is a physical volume. And the physical volume, the combine into volume group number, say the VG, to create LVM, the logical volume. And the volume group create the pool of the disk space, out of which this one, LVM, logical volume, can be allocated. So after the format or creating the file system to this logical volume, we can mount this logical volume to use this kind of the disk volume. Okay, CLVM overview. So now we are studying the cluster, Linux cluster. So here, cluster node 1, node 2, node 3, and node 4. And this one is a shared storage to supply this kind of logical volume to clustering node. So each cluster node will have this daemon CLVMD, CLVMD, and this kind of CLVMD will communicate with each other, and this kind of CLVMD normally will have this kind of information LVM2 metadatas. So each the CLVMD daemon distribute this kind of the LVM metadata update to all clustering node. So all cluster node will have the same information about the LVM from this shared storage. CLVM, I told you, a set of the clustering extension to LVM and the part of resilient storage. And the cluster of computers that manage shared storage SAN using LVM. If more than one node of cluster can access the storage, which is then normally shared among the active node, then we have to use the CLVM. So in this case, the shared storage must be the active. Then we can use the CLVM. The configure logical volume on shared storage by the locking access to physical storage while a logical volume is being configured. So when we use the logical volume, normally this one, locking access will be the work and running. And the user cluster the locking the service to manage the shared storage. So when we use the CLVM, okay, daemon like this, CLVM daemon and the start, and this one is checking. Also, this one too, Linux kernel must support this one, distribute the locking the manager. So if this is working and running well by the Linux the kernel, then we can use the CLVM. And also CLVM provides for storage virtualization as well. Okay, LVM component, there are three. Okay, here physical volume I already explained. The block devices like a partition or whole disk, and the volume group, physical volume are combined to the volume group, and using this one we can create of the logical volume. And the logical volume have this kind of the types, the linear volumes, striped logical volumes, mirrored logical volumes, the RAID logical volumes, and snapshot volumes. So logical volume here, I already told you here, linear volumes, normally linear volumes means the aggregate space from one or more physical volume into one logical volume. We normally say linear volume. So if we don't give any the specific type for the logical volume, normally will be the linear volume. Striped logical volume, I already told you, striping enhances the performance by writing data to predefined number of physical volumes in round-robin fashion. So in this case, we can use the the physical volume to save the data using the round-robin fashion. And the mirror logical volume, the mirror means identical copies of data. I already explained this one too. Different devices to ensure that data written to underlying the physical volume is mirrored onto separate physical volume. Even if the physical volume is the separate, but the separate physical volume will save the same data as your mirror. RAID logical volume support RAID 4, 5, 6, and the new implementation of the mirroring too. So in this wrap, I will show you two kinds of the RAID types. And the snapshot volumes provide the ability to create a kind of the virtual images of the device and the particular instance without causing a service interruption. So even if we don't interrupt the service, we can copy or create virtual image for each device using snapshot volume. Okay, first one, physical volume administration. So at first time, please check your partition types. So if you have the existing partition, then you can use this kind of command to erase all data in this device. In my case, db sdb1, block size, count on, and only field 0. And the initialize physical volumes. So if you have the partition or the whole disk, then we can create the physical volume using this command. In my case, sdb1, sdc1, sdd1 using. And after that, if you scan all for block device, then you can use this command LVM disk scan. And also, you can use this kind of command to display physical volume, PV display, PV scan, and PVS. If we want to remove physical volume, it's very simple. PV remove and partition or the disk name. Volume group administration, first one, now we create the physical volume in the previous page. Now, it's time to create the volume group. So, first one, to create the volume group here, VG create volume create and volume group name and physical volume name. So in my case, SDB1 and SDBC1. So these two, the partition will support or create this volume group. And if you want to create this kind of volume in the clustering the situation, so here -C, then this one will support the creating the volume group in the cluster. So this one no. So if we want to use it right now, then you can change it's a yes. And if we want to see the result about this one, VGS. Physical volume, the add after you create this kind of volume group with the two physical volume, you can add using this command VG extend and volume group name and add additional the physical volume name. If we want to see this kind of result, then VG display and volume group name, VG scan as well. If we want to remove the physical volume from volume group, then first one, please check this kind of the partition information. After that, VG reduce and volume group and partition type. Then this partition will be removed from this volume group. And if we want to activate or deactivate the volume group, then we can use this kind of command VG, the change, VG change. And this one, activate no or yes, yes in case of yes, Y, CV, CY. So if we want to give the clustering flag, then C clustering, Y mean yes or no. Remove the volume group, then VG remove VG the volume group name. And also you can build the volume group. So using this command VG build source volume group here and destination volume group and physical volume. So VG build this one from this is a source the volume group and this is a new kind of the volume group and this one. Okay, from this one now will be used to by small volume. Combine the volume group, so VG merge minus -V mean the bubbles mode and VG1 this one. So this one we have the volume group VG1 and VG2, then VG2 will be combined to VG1. Number 10, backup the volume group the metadata. So after we created this kind of the volume group or physical or logical volume, normally the LVM will save the metadata here, etc LVM backup or metadata archives, then etc LVM archives. And the bridge, the configuration backup normally in this directory, especially the using the metadata. Bridge configuration, the restore the metadata of the volume group from the archive here, or the physical volume. And if we want to rename the volume group, then we can use bg rename. So db bg1 will change to bg2, and the bg rename also bg2 will change to bg1, the name. Logical volume administration. So create a logical volume at first. The create linear, this is a default, so it's very simple. LV create the volume size 100 megabyte and the name LV1 from volume group. So when we create this kind of logical volume, we have to define exact volume group. Also, we can define exact size using the percent. So -L 50% volume group. So this one, bridge1. From the bridge1, the 50% size will be allocated to this logical volume. Striped volume with the two physical volume. I already explained about the striped volume. So at least we need the two physical volume to create striped volume. And the striped size will be 64 kilobps. So for example here, LV create -L 100 megabyte and the volume, physical volume will be 2, and this one, the size of the stripe 64 kilobps, and name stripe LB and VG, this one volume name. So if we want to see the information about this logical volume, then you can use this kind of command. LVS, this one, the all option name, device name, where from volume group 1. If we want to create the mirrored volume here, okay, this one size 100 megabyte and M1 and the mirror volume name, the volume name. So M1 means how many the block, what device will be copied. This one, it means only one. So for example, disk 1, then disk 2, like this. So change the mirrored volume. So after you create the mirrored volume, we can change the type of this kind of volume. For example, from the here convert, at first time I create the linear logical volume, but I want to change what convert to mirrored. Then you can use like this. At first time, please check your information from the volume group. Then after that, LV convert M1 and this one, the linear volume group name, in my case, volume group 1 / the logical volume 1. So this one now will become the mirrored logical volume. And if we want to convert the mirror to the linear, then here, LV convert M0 and the logical volume name. Create a snapshot. So in this case, when we create snapshot, so here we need to give exact option like a snapshot or just -s and name. So snapshot, the volume name will be snap LV and the DV VG1 LVM. So this is the original, the logical volume to the snap. So this volume will be created this kind of the virtual image snap the LV. So snap LV will the backup this logical volume by the time. And after that, DV VG1 the snap LV, then you can see the information LVS as well. RAID logical volumes. So first one, create the two-way RAID 1 array named the RAID volume 1 in the volume group, the bridge 1 and size 100. So in this case, we can define the RAID type. So RAID 1. RAID 1 means the mirroring. So M1, I already told you this one, specify number of the copy. So in this case, only I will copy one disk. And the size and the name and volume group name like this. In case of RAID 5 or 6, so for example, RAID 5, 6, at least 3 stripes, 1 the parity in case of the RAID 5. RAID 6, 3 stripes, 2 the parity drive. So If we consist of RAID 5, for example, then 3 stripe, 1 the parent. So in this case, we need at least 4 the physical volume group, physical volume. So here, RAID 5 here, I mean the number of the physical volume and the size 100 megabyte and the name and where from volume group 1. So in this case, volume group 1 must have at least 4 the physical volume. RAID 6 as well. In case of RAID 6, maybe at least the 5 physical volume. Resizing the logical volumes is very easier. LV reduce, if we want to reduce, then here minus 100 megabyte. Where from? Logical volume 1. If we want to use the LV, the resizing also here, and it's the same. Change the parameters of logical volume group. So in this case, we can use the LV change here. So permission, read, only give the read permission. Where to? Logical volume 1. This one, activate, yes, so to logical volume 1. And if we want to see this kind of information about the special parameters, then we can use LVS. Rename the logical volume here, rename. This is an old name and this is a new name, or this is a volume group. If this one is the same, if to this logical volume belong to the same the volume group, then just the volume group and old logical volume, new logical volume like this. Remove, then LV remove here. In my case, DV volume group 1 and test the logical volume. Display, LV display, LV scan, or PVS physical volume and option the physical volume used. Then this one will show the information. Number 7, the grow logical volume. So general growing. So then in this case we can use the LV extend. So size 100 megabyte for the logical volume 2. Then this one will increase 100 megabyte more. LV the resize, then here plus also is the same. In case of striped volume also same, but we can use like this, LV extend and the stripe volume name and size like this. But sometimes if we fail to increase the size of stripe, then we need to add more the physical volume to volume group. And the mirrored volume is the same. If we want to see information at first time, LVS-V and the segment volume group, and have that large the size 100 megabyte volume group and no synchronization. So if we give the no synchronization, maybe in the parameter or attribute we can see the just M. And the LVS-O-A-O option all, then device, then this also will show the informations. Creating mirrored logical volume. So now in the clustering system, let's try to create a mirrored logical volume. So first one, LVM conf enable cluster. So this file etc/LVM conf will save the main configuration file for LVM configuration. So here locking type must be the 3. So locking type must 3 means this one will running in clustering environment. And after that, number 2, please check the CLV daemon, right? The service start and the process. And if you use this command cman tool service, then this one will show DLM or CLVMD like this. And number 3, in the clustering environment, we need to install the package for mirroring, cmirror-y, and checking RPM and the start and the process checking and register to each the run level. And after that, number 4, create the physical volume. So in case of the mirror logical volume, at least we need the 3 kind of physical volume. So 2, in my case, the STB1, STB2. So this one, the legs of the mirror. And the SDC, this one also type is different. Physical volume for containing only mirror log. So if we want to save the mirroring log for this kind of the mirrored logical volume in cluster, then we have to create this one. So after that, number 5, create volume group. VG create the volume group name and SDB1, SDB2, and SDC1, and after that, press check this information using this command. And now let number 6, create mirrored logical volume like this. LV create -L here. In case of the small l, normally 1000 mean the PE. Normally the physical, the extent. It's a kind of unit of the data. So normally in case as a default, normal LVMs supply the 4 megabyte per each the physical extent. So, and after that, M1, I explained this one too. The only copy one device, and the volume group here, and the name here, and the mirrored, the logical volume. Now I already told you, DV, the STB1 and STB2 will be used for the legs of the mirror. So this one, for example, like this one, original data. This one is backup data, backup disk like this. So SDC1 will be used for the only to save the mirroring log. So in this case, this kind of number 1 to 1000, 1 to 1000, and 0. This mean is a number of the physical extent. So I already told you one extent is has 4 megabyte. So in this case, if we have the 1000 extent, then will be the 4 gigabyte like this. So 4 gigabyte will be created to save the mirroring the data. And the number 7, display the configuration on the mirror. Then we can use this kind of the command LVS -or -option devices. So now I will show you how to use PV, VG, and LV. Okay, now I prepare for the node, 3 node for clustering and the managing. So there are 4 hosts to test the clustering, especially the CL. So this is a manager as the sharing storage, and node 1, node 2, and node 3. At first, in the sharing storage, let's check the physical partitions. So now I have here SDA is using only for this host, but the SDB 1 gigabyte, SDC 1 gigabyte, and SDD around 20 gigabyte. So using the TGT, now ISCSI, I'm now supplying this kind of information. So, TGT admin -s. So now here, so target 1, so run 1 here, SDB, and target 2, disk 2, this one, and this one now supplying the SDC. Target 3, disk 3, now this one supplying the DB SDD like this. So in the node 1, let's check this kind of the partitions like this. I already created this kind of partition, so let's try to use this kind of partition. In my case, here, for example, this one, DV mapper 1IET001001. This one is will be the SD, the B in the shared storage, and after that 002, this one will be this one SDC, and 003, this one will be SDD like this. So I already create this kind of partitions. SDD here, now 1, 2, 3, this one belong to the primary, and 5, 6, 7 belong to the logical partition. And the SDD here, the 1, 2, 3, 4 belong to the primary and the extended. 5, 6, 7 belong to the logical partition. And 003, this one means SDD in the shared storage. So 1, 2, 3, 4 also primary extended 5, 6, 7, 8. This one belong to the logical partition. So using this one, I will create the physical volume, logical volume, and volume group as well. So at first time, please check the cluster node your CLVM. So in my case, so your CLVM daemon must be run in each cluster node. And one more thing, grab DLM. Also, this one DLM must be running in Linux by the Linux the kernel in the as a module. So then now I'm ready to use the CLVM. So first one, physical volume administration. So after I already told you here, let's check fdisk dv mapper 1 it1 001. So p. So I have the 7 partition q, and after that 2. Okay. So also this one too, the SDC, this one, so 7 partitions, and the last one SDD, also this one a partition. So using this one, I will create the physical volume. Okay, first one, P5, P6, P7. Okay, now I create, and the second, now 2, P1, this one 2, second disk, this one second partition P2, and this one 2 partition 3. Okay, and also P5, P6, P7 as well. Okay, and the last one, in my case, the SDD, so 3, P1, and this one 2, 3, the second partition P2, this one the 3, partition 3. Okay, and the last one will be 3P5, 6, and 7. And the last one will be 8. Okay, so now I create the physical volume. So LVM disk scan. So I can see here, okay? This one, 002 means the SD is the C, 001 means SDB, and 003 means the SDD. So I create this kind of the physical volume. So here you can find the exact size here, and the physical volume, this one, for around the 5, and the 5, 6, this one normally 1000 mean the 1 gigabyte, and the 5, 6, 7, this one too, 100, like this. So now the total 25. So LVM using the 16, the physical volume. So here PV display. So we can find the total, the 16, the physical volume like this. So for example, this one, P7 is a new physical volume, and the mapper in this directory, and the size, and physical the extent size, not yet. So we have the we got this kind of information, or PV scan also will show this kind of information to here size, type, and the pass, eject the pass. So PVS is similar, okay, here type, attribute, size, and pre. So size like this. Okay, second, create the volume group. So now in my case, I will create the 4 kinds the volume group. So first one, VG, create VG1. So DV mapper 1, 0, physical volume, the 5. DV mapper 1, IT1, partition number 6, and DV mapper 1, IT1, the partition number 7. Okay, this one will be the volume group 1. Okay, like this. And the volume group 2 using the SDC. Okay, here. So mapper, this case 2, the partition number 1, and this one 2, partition number 2, and this one 2, partition number 3. Okay, now VG2 and VG the 3. Okay, let's create the VG3 here. VG3. So in this case, the partition number 5, 6, and 7. So I create the volume group through. Volume group 4 here. Let's create more. Volume group 4, and this one will be SD D3 and partition number 1 and number 3, partition number 2 and 3, partition number 3. Okay, now I create the 4 the volume group. So let's check VGS. So now I create VG1, VG2, VG3, VG4, and this kind of attribute and the size and the precise like this. Our VG scan also just showing the volume group and metadata like this. And the VG display, then this one will show the 4 kinds the volume group. So this one volume group 3, volume group 4, volume group 1, and volume group 2 like this. So here we can find each volume group has the physical extent size is 4 MB and each the size 600 and 600 and around the 15 GB and around the 300 like this. So now we can see the physical volume and the volume group as well. So now we created the physical volume and the volume group as well like this. So how about the test volume group the extended like this? So VG, now VGS. Then now let's check the VG3, okay, like this. Then VG extended 3, DV3, partition number 5. The volume group 3 has the for the physical volume. So let's check the VG3, okay, and VGS. So volume group, okay. This one at first time VG is just 300 MB, but now 1 GB the 300 like this. Or we can delete this kind of the volume group from the physical volume. So now VG reduce, then in my case VG3 and DV mapper IT3 partition number 5. Okay, then the removed, and after that VGS. So volume group now So 300 like this. So like this we can use the VG extended or VG reduce. And now PVS. So now we can see each the physical volume belong to which the volume group. So now let's try to test the split volume group. So in my case, let's create volume group 4, this one, okay, volume group 4, okay, this one. So using this one, we can create we can split the volume group like this, VG split. Now VG4 and VG5 and DV mapper 1IT3. In my case, okay, this one, partition number 3. So now volume group 5, okay, let's check PVS. So only this one, partition number 3 belong to volume group 5. This is a kind of new the volume group. So now let's combine this one, okay, let's PVS, then merge now VG4 and VG5 volume group destination and the source. The VG5 will be disappeared and the VG4 will be the increase. So now here volume group VG5 successfully merged into VG4 and after that PVS. So now only VG4 like this. So using VG split and VG merge we can combine or split each volume group. Number 10, the backup volume group metadata. So if you go to LVM, okay, here we can find here archive, backup, and cache. So archive, we can find this kind of archive and LV backup also VG1, VG2, VG3, and VG4. So let's read VG5. Okay. So if this is a kind of backup the metadata, so if we see this one the VG5, so the content, version number, description, okay, here by whom, okay, from this the device, host in node 1 and time, and this information ID number, sequence flag, and extent size, and this kind of information as well. So using this one, okay, each the volume group has their own the backup metadata to save this kind of data in this directory. Okay, the rename of volume group. So now let's change the name. So first one, VG rename. Okay, now the VG2, VG1, VG5. Okay, PBS. So now here PBS, VG5, VG5, or VGS. So we can apply VG1 only, VG5. And now VG rename. So VG5 will be VG1. Okay, PBS. Also VG1. Change like this. So if we use the VG rename anytime, we can change the name of the volume group. Now the logical volume administration. So now using volume group, let's try to create the volume group. At first, create the linear logical volume, LV create, and the size, in my case 100 megabyte, and the name logical volume 1, where volume group 1. So LVS, then I can find this logical volume where from volume group 1 and size like this. B, the create the stripe volume with the two physical volumes and the stripe of the 64 kilobyte. So in this case, let's try to use the volume group 2. So LVS, now the PVS. So here volume group 2, okay, this one, 1, 2, 3 the partitions. So using this one, let's try to create logical 100 megabyte is the same, and I is a 2 and hyphen I the 64 volume group 2. So now here stripe volume, then LVS. So stripe volume, okay, size also created. And this one, let's check LVS hyphen A hyphen O. VG, in my case, using that to check VG2. So in my case, I created the stripe volume. So this one using the partition. So P1 and P2, because here I define the two device. In the next topic, I will show you how to create mirrored volume in the cluster environment. Okay, now let's create the snapshot volume. So in my case now, logical volume, I have this kind of logical volume. So here, I will create a snapshot volume for this one, LV2. So now let's try to create LV, create the size 100 megabyte, and the snapshot, and the name will be SNAP LV. And after that, the target DV, in my case, volume group 5 and logical volume 2. So in this case, I can see this kind of the message. So the LV2, the logical volume 2 must be active, the exclusive. So to make this LV2, the active exclusive, we can use this kind of command. LV change AY and target EV volume group 5 and logical volume 2. But if I use this kind of command, we can see this kind of messages. Error locking on node and device or resource busy. So to avoid this kind of message, we have to first A mean the activate, and mean no. So deactivate first. So DV VG5 LV2. So now let's use the command again. So AEY. So here A is activate the yes. So we can see this kind of, and after let's try to create the snapshot volume for the LV2. So now we can see logical volume the logical volume created. So let's check LVS. So here, snap LV, the LV2. So snap LV is the origin. This one LV2. Here can you see origin, the LV2. So according to the LV2, the snap logical volume will save the data from LV2. This is the snapshot volume. Okay, then let's try to create the RAID logical volumes. Okay, at first, the create two-way RAID 1 array named the RAID LV1 in the volume group, and size will be 100. So now, like this, in my case, now I have the volume group. So here I will use the volume group, the 3. So now previously check. So the volume group 3, okay, like this. And the volume group 4, like this. Mirroring, the RAID logical volume is type 1. Is in case of the mirroring, no problem to use the partition or 3 partition is no problem. But RAID 5 or 6, then in this case, we need at least 4 the partition. So at first, let's create the RAID 2. At first, RAID 1 like this, LV, at first the VGS, then let's try to use the VG3. So LV create type RAID 1. The RAID 1 means mirroring, and device will be copy only 1, and after that size 100 megabyte and name RAID 1 and volume group 3. So now LVS. So we can find this one RAID, and this one mean the RAID and the synchronization. So at first time 44%, now 100% like this. But in case of the RAID 5 or 6, but I already told you we need at least the 3 stripes or 1 or 2 parity, or we can define only the 2 stripe, 1 the parity. So in my case now, let's check VGS. So I will use the VG4. So VG4 only the 3. So in this case, I will use only the 2 stripe, 1 the parity drive. So LV create type also RAID 5. And the interface will be 2, 1 the stripe, and the size the 5, and the name RAID 5, and volume group 4. Okay, now LVS. Okay, this one RAID and RAID 2 like this. So if we check, I create the 4 the LV, the logical volumes. So here let's try to use the reduce or the change the logical volume. So for example, logical volume 1, now logical volume reduce -L the 550 megabyte, and this one belong to VG1 LV1. So yes, and of that LVS. So now only the 5. Now let's the increase. So also LV resize -L plus VG1 LV1. Okay, and after that, let's check LVS. So now LV1 is a increase. So using LV reduce and LV resize, anytime we can the resize logical volume. And number 3, change the parameters of the logical volume. So now let's check the LVS. This one, this is attribute. This is RAID 1, RAID 5 is a RAID disk, and the LV1 and stripe has a write. So here LV the change, and okay, permission only the read. Okay, DV VG1 LV1. So change LVS. So now we can find here just read. Again, now let's give the W as well. So LVS. So now change W like this. So using LV change, we can change the parameters of logical volume and rename the logical volume. So now LV rename. Okay, now volume group 1. This one LV1. Okay, now we have LV1. This one let's change to LV2. Okay, then LVS. So now change LV2. Again, LV rename the volume group 1, LV2 now LV1. So and after that LVS. So anytime we can change the name of the logical volume using this command. Okay, display LV display, for example, so if we want to see exact the logical volume information, then we can use LV display like this. The path name belong to the which the volume group, and the UUID, and the permission, and which the create and accessible or not, and size and the block size like this. So using LV display or LV scan, also LV scan and LVS. These three commands is very important to check exact the information. Or let's here LV using PVS-O plus PV used. Now each partition belongs to each the volume group, and each volume group has this kind of size and how much the size used or not, like this 52 or 500 256. So if we want to know the exact the size of the used the volume, then we can use this kind of command as well, pvs the pv underbar used. Let's try to the grow logical volume, the general growing, the extended, the stripe volume. For the extend the mirrored volume, maybe after I created the mirrored volume for the clustering. Okay, first one, let's check the size. I already show you the how to increase the size of the logical volume. For example, like in my case, the LV1, this one. Okay, so here there are two ways. LV extended -L 100 megabyte, and of that DV, which one? So volume group 1, LV1. Okay, using this one, okay, have to the plus, then okay, let's check LVS. Then now 200, or LV, I already show you LV hyphen L, and after that now the 50 megabyte DV volume group 1 LV1, also LVS. So now the size the increased. And the stripe volume, okay, LVS. Now I have this one, the stripe volume. Okay, then let's check VGS, first one, okay, VG1, VG2, VG3, 4, and the size. So here, LV extended. Now in my case, stripe volume 2, RIP LV, and size 100 megabyte. Okay, then LVS. Now the stripe volume, okay, at first time 100, but now 200, and VGS as well. Okay, this one 2. Okay, the last chapter is creating the mirrored logical volume in cluster. So at first, LVM conf and that enable cluster. This one, LVM the conf enable cluster. Okay, and after that, grab locking type must be etc LVM comp. So this one I told you must be 3. Okay, and please check your CLVMD. And now so far I create the LVM for LVS, create the node 1. How about node 2? Okay, here LVS. So also LV node 2 and node 3. Also we can find this kind of logical volume information because each node now is running the CLVM daemon. And after that here node 1. So let's check. CLVM already is running, and cman. So in the cman tool services also you have to check this one, CLVM the daemon. Okay, so in my case now it's working. And the number 3, start a similar service. So for example, rpm-qsc mirror. We need this package, okay, here, C mirror. So if you don't have, just you install C mirror -y. then this one will install this package. Okay, in my case, I already installed this package. Okay, and after that, the service C mirrored will start. In my case, I already start. So please check this daemon as well. See, so this daemon already started. For the registration, okay, like this. Number 4, the create the volume, physical the volumes. So in my case here, we need to create the 3 kinds the physical volume. So I already create. Let's check LVS and the volume group. So this one, in my case, I will use this one. Okay, in my case now I'm using the RAID 5, the volume group 4. So I will delete this one with LV remove. Okay, now LVS. So to use volume group 4, okay, I will use the volume group 4. This one, the volume group. Okay, this 1, 2, 3. Okay, now the number 4, create the physical volume. I already create the 3 the physical volume for the mirrored logical volume in the cluster. So now let's create number 5, create the volume group as well. So volume group. So in my case, I will use volume group 4, this one. So number 5, create the volume group. I already created this. Now just skip like this. Okay, volume group 4 like this. So this one. And number 6, create the mirrored logical volume. So now let's create logical volume. And this one, 1000, the extent, and only one. And in my case, I will use the volume group 4 and name mirrored logical volume and dv mapper 1IT3 partition 1, okay, and extent number, okay, 1000, and dv mapper 1IT3 partition number 2 also 1000, and the last one dv mapper 1IT3 partition number 3, and first the, okay, now logical volume mirrored created. Okay, then let's check LVS, the volume group 4 and mirror logical volume. Okay, so here we can find this M means the mirrored the size, and also like this. And also LVS-A-O and devices. So also we can find the LVS especially about the mirrored, okay, this one, okay, mirrored logical volume informations. So 1, 2, 3, and this one, this volume is just log, okay. Yeah. This is a kind of lag for the mirroring the disk, and this is a log. So only used only one extent. One extent normally is 4 megabyte, and the others now using this one around the 3.91 the gigabyte from 1000 the extent. So using LV create and the similar package, we can create mirrored logical volume as well. So how about node 2? So we can find also mirrored logical volume, and volumes node 3 also we can find like this. So far I show you how to use the PV, VG and LV, especially the mirrored volume in clustering the environment. The next chapter maybe will be the chapter 11. There I will explain the GFS. So in chapter 10, we learned how to create the logical volume and physical volume. So now our next purpose and aim must be use this kind of volumes. So the next chapter in GFS, I will show you how to make the file system using the GFS and the other things for this kind of the volume. And of that, we need to mount this kind of the format or file system to use or to save the data. So in the next chapter, I will show you two kind of things more. How to create the file system for volume groups and how to use this kind of the data using mount. Okay, chapter 10 summary. In this chapter, you study these kind of things. First one, what we use the LVM for. So for what we need to use LVM. And the second, what are three components of LVM, especially the three things. Number three, what are the main comments for three components of the LVM to manage three this kind of components. Normally we use some comments. Number four, what is different between data striping and the mirroring? And number five, what are the preconditions to use the CLVM? And number six, what do we need to use the clustered mirrored logical volumes? And number seven, what is the command to create a snapshot volume using volume group? Okay, thank you for watching this video. God bless you. See you in next chapter.